All right, number 19 says, a point goes along the curve, y equals x, or y equals the square root of x. Okay. So we have a point moving on a curve. So the first thing we can do is we can draw a picture. Right, do you guys remember we draw a picture for this one? It's really just this.
Is this a related rate?
This is a related rate thing, yep. So you have this point right there, right? And it's just moving on that curve, okay? And remember that that means that the x-coordinate is changing and the y-coordinate is changing with time. So if I push play on our DVD player, I know nobody uses those things anymore, but if I push play on it, it would go, right? And it would move this way with time. So our x changes with time and our y changes with time, okay? So let's define our variables and our constants. So our variables are x and y. Those are always changing, right? And what is constant in this equation? So that's our freeze point, y equals 2, because y is not always going to be equal to.
dy dt is always.
Yes, dy dt is always constant, and that is always 4 centimeters a second. Okay. So anything that's a variable has to stay in the equation until after we do our derivative. Anything that's constant can be plugged in before we do a derivative, but there is no rate of change before we do a derivative, right? So there's nothing we can really plug in first, okay? Let's talk about our freeze point. When do we freeze this?
Y equals 2.
Y equals 2, we freeze it.
So you have to go back to the first equation and plug 2 in.
Yeah, so let's find out what x equals at that point too. We'll find that we probably need that later on, but let's go ahead and find it right now. If y equals 2, what did x equal? 4. So at our freeze moment, y equals 2 and x equals 4. A lot of times, especially if you have a triangle one, you have to go back and figure out what they were, you know, because they're only going to give you 1 or 2 of the sides, and you have to find the other ones. Okay, so we have then our equation. We already have our equation. I'm kind of writing it. I didn't put the little thingy up here. So we're writing it like that. Y equals not 2. Y equals square root of x. That's our equation, right? And you know what? We'll rewrite it so that it's easier to differentiate. But remember, I didn't actually take a derivative when I rewrote it. I just rewrote it. That's something a lot of people like try to rewrite and derive at the exact same time. I wouldn't do that. I would rewrite it and then derive. Okay, so now we're going to do our rate of change. Our rate of change equation. So we have dy dt, right? The change of y with respect to t equals 1/2 x to the negative 1/2 dx dt. Does everyone feel pretty comfortable doing that part? You feel good doing that? Differentiating.
Yeah.
Okay, so we feel good differentiating. All right, and then all we have to do is we have to figure out what was going on at our freeze point. So this is at any point, the rate of change of y equals all of this mess. So now we got to figure out, oh wait, what were we asked to find? I guess I never wrote that down. The rate of change of x. Yeah, so we're finding dx dt. Okay, so then I just plug in my freeze point. I plug in everything that I do know, which I know that dy dt is 4, and I have 1/2, and then I know that x is 4. So 4 to the negative 1/2, and then I do not know dx dt. So some of you can do 4 to the negative 1/2 in your head, but if you can't, you would just do 1/2 and then make sure you know that that's, you move that to the denominator, right? That's just 4 to the 1/2 in the denominator, dx dt. So that's 4 equals 1/2 times 1 over the square root of 4 dx dt. You do not have to write all of this algebra, but in a stressful situation, I would suggest not trying to jump from here to an answer, just because when you're stressed, your brain, your new synapses in your brain shut down, and you might make a mistake. So we end up with 4 equals 1/4, right? Because that's 1/2 times 1/2. And then I multiply both by 4 and I get 16 equals dx dt. So that is our dx dt, but that doesn't answer the question, right? Find the rate of change of the x-coordinate with respect to time. So we need units on this, don't we?
Centimeters per second.
Yes, that's the only thing we have to add here. Sometimes it will ask you for a full sentence that says, like, what does that mean? We would say the x-coordinate is changing at 16 centimeters per second when y equals 2. Yeah. Or if you had something with, like, a ladder or something, you would want to make sure to state, like, the ladder is falling down the wall at this many inches per second. Okay? Does that help on that one? Do you guys have another one you want to do together? You just want to work?